Hi, in this series, we'll be continuing to do the GCE A-Level H2 Mathematics 2022 Paper 1. So for question 5, they are testing you on a little bit of interaction between geometrical objects between a curve and a line and see whether you understand how to solve such questions. So what do I mean by that? Well, you are given a curve which is a equation of a circle. So you got a circle over here. And you know that a line is tangential to it. So you got two equations, and normally how will you solve for the point of intersection is, well, you just take 2 sub into 1, right? So let's just do that. So you just take 2 sub into 1 and you get this equation. If you expand out, you get this giant equation. Then now you must think, how will you solve for x? Well, you must first reduce this and simplify into a quadratic equation. So you don't care about the terms in m because they just will be some number in the end. Then you got these values. Then you must now think, it's weird because now we have an equation in x, but we want an equation just in m. But if you recall, when two lines meet tangentially or meet when there's only one point of intersection, remember when you have a quadratic curve and it has only one point of intersection with the x-axis, it means that the discriminant equals to 0 for the equation here. So it has only one solution because it only touches at one point. So we know that the discriminant equals to 0. Now we can solve because the discriminants will just be in terms of m and constants. So that will help us to get this equation, hopefully, which it will lah, because that's how the questions are usually phrased. So you must recognize to use the discriminant and just do b squared minus 4ac, and you expand out and you get this, and then this simplifies into what we want. So you're done. So you can see how we run through the thought process. We first submit to solve normally our x, and then we start at some point, but we know we want something in terms of m, and to do so we just need the coefficients, and that will lead us to thinking to use the discriminant method to get the coefficients only. And now the discriminant, you realize that because it's only touching one point, we can solve it. So I hope it's clear how to do part A. Moving on to part B, it says that two tangents intersect at the origin, meaning this tangent line is some form m1x and this one is m2x. Because it's intersect at the origin, it's like plus 0, so you don't really care. So you can see these two equations, they're just saying this part again. But because this is a general m and you got a quadratic, so this will lead to m1, m2 lah. So basically it's saying to solve part A. So you must solve part A and you get two m's, which is one of them is m1 and one of them is m2. Now you just solve m1 in to the equation and solve for x, and you know it's just 1 point, and then you solve for y. Then similarly you sub the m equals to minus 18 into the equation and you solve for x, again 1 point, y. And you see that the coordinates are as follows. So that's all for question 5. If you have any questions, just leave it down in the comments like always. Now we'll move on. Question 6. It tests you your understanding for transformation of curves. So you got a function over here, and you're supposed to describe a full sequence of transformation that leads you from 1x over x to fx. Well, you can solve it in this form, but what I like to do is, of course, do long division, because I know this is a power x here and this is a power x here, to simplify it first. Then we'll see. So now we just need to get 1 over x to this form. There's many ways to do it, but for me, what I like to do is always multiply the constants first before doing any translation. You might ask, why is that so? Well, that's because when you translate already, then when you scale, then you only change this portion, then you need to take note. Then it will change the constant as well. So you might as well just scale first, then you leave the x alone, then you scale it with x. So this is the top by step process to getting what we want. And you don't really need to write this down in the exam, but you need to write these 3 lines. So you first, so this is your thought process, then you write it out. So in the end, you can just erase all these parts, you know. So the thought process goes as follows. So we first need to scale parallel to the x-axis by a factor of x plus a squared. This means you change x to x over k plus a squared. And because it's reciprocal, it becomes this. Then you translate it, because it's minus, so it's like all your values, you just shift right to become bigger by a units. And then now we got this plus a plus something. So this is basically saying from y equals to a squared over x minus a, you translate it by a in the positive x direction. This changes y direction, so this changes y to y minus a. Then this like that, and then you just bring this over and you're done. So that's the full sequence of transformation. Next, we're supposed to find the inverse, and because y equals to this, so to find the inverse, you always let the y equals to fx, and then now you want to get x equals to some gy, some function in terms of y. And then now you just need to replace this with f inverse x. And this will be just the inverse function. So you just need to you want to shift x to the left hand side and write in terms of everything in terms of y. So you do the following, where you bring the minus a over, and then you divide, bring up, which is what I did, and then you just bring the a over, and you realize it's actually x equals to this. So that means if we now change this x to y and this y to x, so y equals to a plus k a plus a squared over x minus a, this will become f inverse x, and you're done. So f inverse x is this, and you actually can see that now it is exactly the same function as the top. Hence, if you want to find f squared, you can write it now as f circle f, right? But then f equals to f inverse. So f circle f inverse equals to the identity function. So it's just back to x. But now you must have you must impose the x cannot equals to a. And if you want to find f to about compose 2003 times, then you just do it like that. So you just, f, then you circle f 2022. But then f 2022, because this is even, it will reduce back to the identity, so this is just x. So it's just, this thing is the same as fx. So you just sub x as 1 and you get the following. Next, for question 7, you are supposed to show your skills in differentiation and solve for the turning point. And you must just know that the turning point means dy dx equals to 0. Because it's like that, then like the tangent is like horizontal. So just take the function and then you differentiate using the chain rule and the power rule. So just power rule it. So you just differentiate the first term, keep the next, then you keep this, differentiate ln x, which is 1 over x. Then you simplify, then you're done. To find turning point, you're supposed to solve for dy dx equals to 0. So this equals to 0 means ln x equals to 1/3. And that means x equals to e to the power 1/3. This means that y equals to e to the power 1/3 to the power minus 3 ln e 1/3. This part is just 1/3. And this part is just e to the power minus 1. So the coordinates is e to the power 1/3, comma 1/3 e minus 1. So I hope it's very clear how to do it step by step. And the thought process. So now we're supposed to find the area, and what I personally like to do is always either use the GC, or if it's a curve that I already know, like maybe x squared or circle, what I really like to do is you draw it out first. Why? Because you don't know whether when you draw it out it could look something like that, and then you need to treat this portion and this portion differently. Because this is like the positive area, negative area, so you need to times negative to this negative area to make it positive. So you draw the curve and it's very nice, so it's just like that, nothing too worrying. So you can just integrate normally from 1 to 3. So you just integrate 1 to 3 for x to the power minus 3 ln x, and in this case you just need to recognize to use integration by parts, where you differentiate ln x. You keep ln x first, then you integrate x minus 3 because it's easy to integrate, then you differentiate ln x times the integrated portion, and then you slowly do it and simplify, and without careless mistakes you should arrive to the answer. So now you might be asking, how do you know which part to integrate? So you can see this part can be broken actually to x minus 2 times ln x over x, and this portion can actually be integrated now to this. But you don't want that, because then because the x minus 2, when you differentiate it will get back to x minus 3, and then it will continue on. You can try it yourself. So you realize that failed, and then you just go back to the simple technique of just keeping ln x, then later differentiating it, because any polynomial can be very easily integrated. So the last question for this video is just doing integration. So it's your techniques of integration. So how do you want to integrate such a form? Well, you already know that it's a proper fraction, because here's power 2 and here's power 1 only. So what you need to do in this case always is recognize that the derivative of the bottom is some linear function, because it's 2x plus 2. In that case now, what you want to do is make the top 2x plus 2 2, so that you can get this ln function at the end. So you make the top 2x plus 2, and then you get this, but you know this is minus 1, so you do minus 3 off, and then x squared plus 2 it straight away can be written as x plus 1 squared. So this portion now can be integrated easily. Well, this also can, because this is just ln. Because when you differentiate ln, it becomes 1 over x squared plus 2x plus 1 times the derivative of the inside, which is this. So this gets here. And for this, because this is just 3x plus 1 to the power minus 2, this portion, because the derivative inside is 1, you can just integrate it normally, and it will be this. Because if you differentiate this, you get this. So a very easy way to check whether your integral is correct is just differentiate your result and see whether you get back what you want. And the next step is to find the exact value of this. Well, this is basically this. So you might be thinking, how are we going to use part A, right? If here as a modulus, we must draw the modulus curve, and you see that the modulus curve from 0 to half, this part is negative, and this part is just 2x minus 1. So we need to split the graph again into 0 to half and half to 2. And when that is so, the modulus can drop and you can replace it with the function that it is. In that case, now you know this is the minus of this, and so when you integrate it, you just do a minus sign, then you put the integrand in and 0 to half, and here's the integrand directly, half to 2, and you just sub in all the values, and show no careless mistake, and you should get minus 2 ln 3 plus 4 ln 2. So what I see from the middle questions in 2022 is very routiner and very calculative. So you're supposed to calculate this use transformation. Okay, so this is not really calculation. And then for x 7 and 8, they are basically all integration techniques. So that's all for this video. I hope you have enjoyed it, and in my next video I'll be wrapping up the paper 1. Thanks for listening and have a good day. Bye.